Okay, we recall the definition of continuity. Function f of x is continuous at a if the limit as x goes to a of f of x equals f of a. That's the definition. Hopefully we've made some sense out of that definition, but here we're just going to quote the definition and do what it says to test continuity. So we want to test the continuity of f of x equals 1 over x minus 2 at x equals 0. So how does this fit into this definition? You should think about that if you haven't already. The answers, well, what we want to do to determine the answer, if it's not completely obvious, is write down this expression, limit as x goes to something of f of x equals f of something. Okay? And then we want to determine what that something is. Of course, that something is a, but where's a in this? Well, f is continuous at a. This is supposed to be continuous at x equals 0. This tells us that a is 0. So we're trying to determine the continuity of this function at x equals 0. We're going to let a equal 0 in the definition. So a is 0 and goes here and here. Now we've written out the exact symbols of the definition, simply replacing a by 0. Now we're going to replace f of x. F of x is 1 over x minus 2 in this case. So f of x becomes 1 over x minus 2. And of course then f of 0 is going to become 0 minus 2, because we're going to plug in 0 into the expression for f of x. So we've translated this expression here, this test for continuity, into this statement, limit as x goes to 0, 1 over x minus 2 equals 1 over 0 minus 2. Okay? Now, question is this true? So we can kind of put a question mark over the equal sign. That's what we're really testing. Is this true or is it not? Okay, well, the limit as x goes to 0 of 1 over x minus 2, well, as x gets closer and closer to 0, there's no doubt that x minus 2 is going to get closer and closer to 2. If x was 0.0001, then x minus 2 would be negative 1.9999. I think I got the right number, 9's in there, which is very close to 2. And the closer x gets to 2, the closer x minus 2 the closer x gets to 0, the closer x minus 2 is going to get to 2. So that this denominator is going to approach negative 2, and then 1 over that negative 2 is going to approach negative 1/2. So this limit is negative 1/2. Now, is this so? Well, and I might have written out another step here, but let me back up. Okay, this is what we get by taking the limit, and this is equal to negative 1/2, and this matches this. So the answer is yes, these two are equal. This limit is negative 1/2, and this expression gives us negative 1/2. Okay, so the question is this. Yes, I wrote yup down here to answer the question. It follows that f of x is continuous at x equals 0.